So I have the challenge now to keep you awake after lunch. I hope I managed to do that and tell you a little bit about Cemvita and what we are doing that for making oil with precision fermentation. So a little bit about Cemvita. Cemvita was founded in 2017 by the siblings Moji and Tara. So Moji comes from oil and gas industry, and Tara has a PhD in life sciences. Both are invested in developing green technologies for production of different chemicals. Our company is based in Houston, which is very strategic for partners with oil and gas industry. And what Moji and Tara built over the years was a multidisciplinary team with biologists, scientists, engineers, and entrepreneurs. Today, we are a team of 37 employees coming from 11 countries. So diversity is also part of our company core. And we do have a mission of all doing industry that is inspired by nature. And as you know, and as we have been hearing within the last days, it is very important to pay attention and to understand why we need green technologies and why it is necessary to find replacements for productions of some sort of commodities. One of the commodities Cemvita is working with, it's for production of oil using precision fermentation. So I just brought here a couple of data where you know there is an increasing demand for oil within the world, where we are expected to reach 321 billion by 2032. And this oil demand, it goes into various sectors. So you are a knowledgeable audience. I don't have to tell you why sustainable aviation fuel is important, but what is needed to know is, for instance, you can do sustainable aviation fuels starting with oil as a building block. Well, sustainable aviation fuel, it is associated with a peak of greenhouse emissions. It does have now pressing from consumers. So we solve this problem and reduce the amount of CO2 that is emitted when we are flying. We have winters that are mild, summers that are hotter than ever. So we have pressing population, pressing governments and politics in order to come up with new policies where we can reduce the amount of CO2 that is emitted by sustainable aviation. You have, for example, here in the United States, the commitment of having 30 billion gallons of sustainable aviation fuels produced by 2030. We do have in Europe the Euro refuel, where it's supposed to increase the demand by sustainable aviation fuel by 2.8 million by also 2030. We do have Brazil, a leading country on green technologies, that it's also have a mandate that starts now in 2027 for reducing emissions by CO2. What Cemvita is contributing there, we have our key partner United, where United compromises to buying from Cemvita 1 billion gallons over 20 years from our sustainable oil. So when we think about sustainable oil, and I made you a link with sustainable aviation fuels, we also have to see that there are plenty of other applications on our day-to-day life that it's important to talk about. So what you see here in my slide is, for instance, one growing market is that the plant-based meals, where you do need a couple of proteins that are also made by precision fermentation, but it's also well known that consistency of your plant-based burger or your plant-based fish, as you see on the picture, will be given by specialty fats. So you will need a couple of specialty fats that will be needed for the formulation, so you think that you're really consuming a meal that is not plant-based. And as you know, animal-based diet, and please don't judge me because I love my meat coming from Brazil, but it is also a high footprint for carbon throughout the world. You have many other applications within personal care, as you see here on the picture, for nutraceuticals and different ingredients coming, for example, from the palm oil industry. And as we have an exponential population growth, we also have a couple of challenges associated with vegetable oil, right? So we do have high land usage. It is associated with deforestation, soil damage, water pollution, and air pollution. So it is important to come up with different processes that can provide such oils and do not cause such a high damage throughout the environment. So what Cemvita is doing is converting a couple of feedstocks throughout precision fermentation for production of sustainable oil. And what we have been thinking about, it's about versatility of our feedstock utilization. So we are very well aware that feedstock depends on the region. That's why we are here and we love the corn from Nebraska, but that varies from region. So it is important that depending where your plant is located, you do have the ability of converting the feedstock that is available. We look into our process end to end, and we had the numerous examples earlier this morning with Chivo, Gino, and Ivan Lanzatek saying how important it is to combine biology with engineering and looking at your process from end to end. So we do look on the overall end. We try to reduce important natural resources like, for example, water. We do look into minimizing water waste and reutilizing throughout our processes. Our microbes that you see in the picture, we like our microbes very, very fat with lots of oils. They can accumulate up to 80% fats per biomass. That's at bench scale. We have a fantastic DSP team working on a protocol for recovering this oil and not using solvents. And then that, of course, generates less land usage compared to, for example, vegetable oil. So the way Cemvita does that, and we put together an end-to-end pipeline, innovative pipeline, where we use and we look into different feedstocks, as you see here on my slide. We do care about selecting microorganisms. That microorganism goes out throughout rounds of genetic engineering and improvement. Then we rapidly transfer that to scale up, and we work very closely with our pilot facility. So in-house, we do have a facility of up to 1,500 liters for accumulating. During scale up and oil recovery processes, our engineers think about how we can reduce operations and cost of equipment. So what you see here, it's during our pilot facility, we do think about materials that are cheaper and are more competitive, which can reduce the cost of our final product. Our downstream processing, as I mentioned, does not use any solvents, which also reduces cost of operation and also reduces carbon footprint. So you might think that pipeline, it's not very original, so let me just walk you through what Cemvita is doing that is differential between other technologies that are already present in the market. So first of all, we start looking very carefully into the microorganism that is producing our oil. So we do look for microorganisms that are not conventional, and conventional microorganisms are the ones that you will find that are engineering throughout production for different products, right? What Cemvita does, it's leverage nature's diversity and versatility. So we do select microorganisms that are not conventional and therefore not directly or easily engineered, but they already have some properties that takes an advantage of being prepared for the harsh conditions that scale up. So for example, our proprietary organism for oil production, as you see here on the picture, you do have two organisms that are known to be hosts for engineering and production throughout different industries. The first one is Saccharomyces cerevisiae, known as baker's yeast. The second one is Yerrovia lipolytica, so the most well-known oleaginosus yeast. And what you see further on my left, it's Cemvita microorganism that is able to produce up to 3 times more oil content. And as you see, when we are selecting our microorganism, more than oil, we do look into other conditions that will favor our scale-up process, and then we will ease this process as we walk into the pipeline. So once this microorganism is selected, what we do is we run our pipeline that is integrated for strain construction, process development, and scale up. So what you see on the slide, it's an example of a design, build, test, and learn cycle, where we start from the beginning with our already pre-selected wild type organism. That organism, it's optimized even further for oil production, and for that we do use bread and butter tools for genetic manipulations, pathway assembly. We do work with AI models in order to streamline strain construction. That goes through our pipeline for high throughput evaluation, and then after we down select the highest producers or the improved strains, that goes into our fermentation team that test and do process development at 100 and 1,500 liters scale. What is interesting here is early on we start testing our microorganisms at larger scale. We can address earlier the problems that sometimes are left on the second plan, and you have folks spending more time on engineering without addressing possible problems that happens at scale. So we are able to incorporate all the challenges that we see at that scale and bring back and learn in order to improve further generations of strains. So a little bit about our pilot scale. It was constructed last year, and it's, since then it has been operating in batch mode for oil production. Here, the first initial batches were mainly dedicated for producing samples for our future partners. And what we are doing now, it's transferring all the process that was developed in smaller scale for that scale, as well as we partner with other CDMOs in order to transfer and scale up to 15,000 liters. So we are very aware, and we worked since the beginning on technical economical analysis for our process. And what we have been doing, and as you can see here today, with the process we have development, we have a final production cost of our oil a little bit above $2 per kilo of lipid. And we have been drafting a roadmap where we will focus on increased biomass productivity and therefore oil productivity, increases extraction yield, operate in a semi-continuous mode, do media optimization, and as I mentioned, we do water recycling and biomass recycling in order to drive the cost down. The goal is that by 2026 and during the year of 2026, we will be able to scale up our process into a cost that is cost competitive with, for example, palm oil industry. So what is the Cemvita way? We do have a stewardship for nature. We have, that is within the core of our company, and what you see in the picture, it's a couple of volunteers earlier this summer after burial, so where we were cleaning the park. So it's not only about the process we have been developing, but it's also a way of life, a sustainable way of life. We do have a dialed in on product development, so we are on track for our first commercial plant that should be operational by 2026. We have now expectations to groundbreaking now in Q1 of next year, and we do have an integrated pipeline that combines synthetic biology and process development in order to deliver a product that is sustainable, but it's also cost competitive. So I think that's it. Thank you very much. We are in the middle of our Series C fundraising, and we have been talking with folks that are interested in collaborating with us within the next stage of Cemvita development, but also we are very interested in developing partnerships with feedstocks, scale up, and etc. So Tara, one of the co-founders, is also on the audience, so come talk to us. Here's our contact, and if you're in Houston, please come and visit. Thank you very much.